Okay, this video is synthetic substitution. This is very similar to synthetic division. As a matter of fact, we're going to do exactly what we did in synthetic division and simply look at the remainder that's left over because it has a very interesting fact about it. So let's imagine that we have a polynomial expression and you are being asked to find the value of y when x equals 3. That is simply a plug-in problem. So the old way would be to say, well, every place that I see this x, I'm going to plug in a 3. So I would do 2 times 3 to the third power minus 5 times 3 to the second power plus 12 times 3 plus 6. And I would do, let's see, 3 to the third power is 27, so I multiply, I get 54 minus 5 times 9 is 45, 12 times 6 is 36, and I work this all out and I come up with 51 as my answer, okay? And that's just fine. But the more complicated our polynomial gets, the more powers that I have, the more variables that I have, the more terms, the harder and harder traditional substitution to find an answer is going to be. It's very simple with a linear, it's very simple with a quadratic, but we want some other options when it starts to get complicated. So let me show you some other options. The other option is to set it up, a little bump there, to set it up the same way we did synthetic division. So there's an equation and I want to find out the value when x equals 3. So just like with synthetic division, I'm going to pull down my coefficients. I put a 2, a negative 5, a 12, and a 6. And then over here I want to know what the value is when x equals 3, so I put a 3 here. Bring down my first coefficient. 2 times 3 is 6. Add them up and get 1. 1 times 3 is 3. Add them up and get 15. 15 times 3 is 45, add them up, and my answer is 51. I didn't have to square anything, I didn't have to cube anything, I don't have to multiply something times the fourth power. So in this way, some of them get more complicated, but the reality is I'm less likely to have to use a calculator. So let's take a look at what if I had to put an 8 in here. That would make it much more complicated. I start the same way, same coefficients, because it's the same equation. Bring down the 2. 2 times 8 is 16, add it, get an 11. 11 times 8 is 88, add it and get 100. 100 times 8 is 800, add it, and my answer would be 806. The value of this equation when x equals 8 is 806. Okay? I just want to show you, just by comparison, how much fun that last one was if I didn't use synthetic substitution, but I actually plugged in the traditional way. First off, I don't know what 8 to the third power is off the top of my head, so I would have to have either a calculator or do some multiplication. So I'm going to have to find the third power of 8 and then multiply it times 2, then multiply 5 times 64, and then 12 times 8 and add 6, and it's just a more complicated problem. Now I want to show you one thing before we finish this, because this is the gist of the entire lesson. I want to remind you that when we had synthetic division, we talked about the importance of keeping it in standard form. Meaning, here's an equation that says y equals 5x to the fourth plus 2x squared minus 6. So there's no x to the third term, and there's no x term, so I don't have standard form. When I bring my coefficients down, I must now put placeholders in that place value. 5, nothing, 2, nothing, negative 6. Okay? I have to have that in the right form and put zeros if there's nothing there. So I want to know what the value is when x equals 3. So I put a 3 over here, bring down my first coefficient. 5 times 3 is 15. Add straight down. 15 plus 3 is 45. Add straight down. 47 times, did I say plus, times 3 is 141. Add straight down. 141 times 3 is 423. This is the only one that I might have needed to use a calculator for or sit down with a pencil and paper. And then I add straight down and I get 417. The same as I would have gotten if I had taken 3 and raised it to the fourth power, multiply it times 5. Now take 3 and square it, times 2 and add that to it, and subtract 6. Okay? This is the exact same procedure, and it works because the place values are set up properly. When can you use this synthetic substitution? Anytime that you're given a function and a number to plug into it. I could actually do this with a linear function. which we wouldn't need to because a linear function is so simple. But any function that you're given, y equals something, you can plug in the number for x using synthetic substitution, the same way that you did for synthetic division.